Hello everyone, my name is Nageshwar and I'm student of IIT Guwahati pursuing BSc Honours in Data Science and Artificial Intelligence. Today I'm presenting you my term project on Multilingual Health Advisory System. In this project, I developed AI-powered health advisory system capable of answering health-related questions in multiple languages using retrieval augmented generation architecture. Healthcare information available on internet is often scattered across different sources. User may receive inaccurate information or generate gen for general purposes. AI model can cause hallucination. Can AI models can generate inaccurate result, especially in the healthcare, which is problematic. Therefore, the objective of the project was to build a multilingual health advisory system that can retrieve information from trusted healthcare documents to solve healthcare documents and provide the answer to the user in their native language. To solve this, I implemented RAG architecture, which uses I have used For this, I have used RAG architecture, which uses the knowledge base, which is create the trusted documents from health and and convert and combines it with LLM power and stricting it to only use the knowledge base and present the and answer the user query in most accurate and most informative way, focusing on the knowledge base. The tech stack used here is Python, LangChain, uh, RoomDB for vector database, sentence embedding from Hugging Face for embedding generation. Then for LLM, I have used Llama 3.3, 70 billion parameter versatile model, and used a RAG pipeline to generate response from knowledge base and combining the power of LLM to give the user output. As we move to our VS Code, as you can see here, I have used PyPDF loader for loading different documents for related to healthcare, and we have checked the validation of the data. The data is then extracted, and the extracted data is shown here. Then I have used the text filter. Then I have used the text filter, which have converted the text data into different small chunks. That is then converted into embeddings. And for chunking, we have taken the size of 1000 and overlaps of 200, because as healthcare is a very sensitive area, so we have taken the over chunk overlap to 200, because in one chunk there can be a problem disease, and in other chunk there can be the precautions, or in the third chunk it can have the solution. So we have kept the chunk overlap to 200 to match and synchronize the chunks. Then here we have the total chunk size. Then we have used Hugging Face embedding model sentence transformer to convert the text data into high dimensional vector. As you can see, we have downloaded the model from Hugging Face and then tested it on our simple query that shows the embedding of 384. Then we have generated a vector database using and use the Chrome database for our project. Then created the vector database named Health Advisory and implemented the embedding model, then converted the text data available into the embeddings. As embeddings are the data that high dimensional data, and we have converted the text data into the high dimensional data, as you can see this. Then we have counted the total number of vector data embeddings that we have in our vector database. Then we have done a simple similarity search of k is equals to 3, in which it shows us the top three most similar chunks from the vector database, the embedding, and present us the most three top searches. Here you can see the top three similar searches. And then we have checked it for top five. And here is the similarity score, which is very good. It shows a very much similarity as we have done the chunk size to 200. Then we have used a simple retrieval function, making it search and similarity search, setting it to 3 and checking it for our checking it on our data. And the result is shown in here. And then we have used LLM power, large language model, NLP's power to convert this information into a structured and representable manner. Say for this, we have used a Llama 3.3 70 billion versatile model. We have tested the model on simple search query. And here we have make a simple and traditional pipeline to retrieve the query from the knowledge base and combining it with the LLM using the prompts that are shown here, that follow a strict guidelines to the LLM to follow a structured way of answering, and the limiting its uh, limiting its boundary to the knowledge base. And we have made a rack pipeline, and now we have tested this. And I have tested this with a simple query of symptoms of diabetes. It has followed the structure of the prompt: overview, cause, symptoms, diagnostic, risk factor, and many more. Then we have tested this on another query. It has worked fine. Then we have tested our multilingual system. We have used Bengali language for this, and we have used in this query, and it has converted the data and proceed in the structured way. Then here we have done the evaluation matrix for our RAG system, and the evaluation matrices shows the result of the our rack system, which have a chunk size of average chunk size of 142 and a chunk length of 7, minimum chunk length of 7, and chunk maximum chunk length of 188. The total chunk length, the maximum chunk length that our chunk can have in our data is this. Then we have used the average similarity, which is around 50% between these queries. We have checked the similarity. Then we have searched for TSN visualization for knowledge based embedding. So this TSEN visualization of knowledge base is it represent and here the each point in the graph represents the individual document chunk after the converting it into vector embeddings. Vector embeddings, as we know, are the high dimensional vector spaces, and show and the dots, the points that are closer shows the high similarity, and the points that are apart from are at very high distance shows the dissimilarity or different topics here. So the visualization of this SEN validates the embedding model, perceiving cinematic relation among health documents, enabling effective similarities based retrieval. And we have done this question and latency. We have checked the latency in healthcare. The the getting the result in very quickest time and correctly is one of the most important things. So we have checked the latency also, and it shows very fine. So for the future development in this system, uh, I'm looking for adding text to speech feature in the model, and as the model can read only the textual data, I'm going for future. We are going to implement the system to search and retrieve information related to image. As the chunk size is very low, we have included very small amount of data. For the future development, I'm going to include more amount of data. There are many limitation in the project. As the data source is very low, it can sometimes present answers, and it can sometimes the query asked cannot give the answer to the related queries. So, and this is the project. Thank you.